Hi everyone, welcome to this lecture. So in this lecture, we will solve a numerical example on least square method. So this is the dataset which I have selected in order to solve a numerical example on least square method. So this is the simplest form of a dataset where we have only two samples and we have one feature which is experience in years and our target value which is salary in dollar. So we have two samples for this dataset. Now we know that in order to implement least square method or in order to solve a problem using a least square regression, we need to construct three matrices. That is Y matrix, X matrix, and W matrix. So Y matrix is the matrix of target variable. So my matrix will be obtained from this column. So it has two values, 30,000 and 50,000. Next, we have a feature matrix. So we have only one feature. The values are 3 and 5. So these two values are at the second column of X. Then we have only one weight because we have one feature and we have one bias. So this is our weight or W matrix. Now, in order to multiply X and W, the condition is that the number of column in X matrix should be equals to the number of rows in W matrix. Now, W matrix has two rows. So we have to create another column in X matrix. So we need to append one at the first column of our feature matrix. So we have also seen this step during the derivation of least square regression, that in order to keep the multiplication possible between X and W, we need to append one at the first column of the feature matrix. Now everything is set, it's time to apply least square method. So the first step in least square method is to take the transpose of X matrix. So this is our X matrix. Now the transpose of X matrix is here. In transpose, we transform the rows into column. The first row is 1:3. So we have transformed it into a column. Similarly, we transform the second row into a column. So in this way, we have an X transpose. Now the next step is to multiply X with X transpose. Here we are performing the multiplication of X transpose and X. So this is my X transpose matrix and this is my X. So the size is 2 by 2. Therefore, we can easily multiply both these two matrices. So when we multiply X transpose time into X, we will get this matrix. So basically this one will multiply by this one. Then this will be multiplied by this. And then we have to add. That's why 1 time 1 is 1. 1 time 1 is 1. And when we add, we will get 2. Similarly, this one will multiply with 3. And then this one will multiply by 5. Then we will add them and we will get 84. So similarly, the multiplication of X transpose and X will result into this matrix. So next step is to take the inverse of this matrix. If we take the inverse of this matrix, so this is a very simple matrix, just 2 by 2. If we take the inverse, we will get this value. So we have completed the calculation of this part, that is X transpose time X. And finally, we have taken the inverse of this product. Now, the next step is to multiply X transpose into Y. So the next step is X transpose into Y. This is my X transpose and this is my Y matrix. So the size of this matrix is 2 by 2. So this matrix has two columns and this matrix has two rows. Therefore, the multiplication is possible. So after multiplication, we will get this result. Now, the last step is to multiply X transpose X inverse and X transpose into Y. So we have to multiply these two matrices. So we have already calculated this matrix, which is here, and we have already calculated this matrix X transpose times Y. And now this matrix is here. If we multiply these two matrices, the multiplication is possible because the number of columns in this matrix are 2 and number of rows in this matrix is 2. So this will multiply with this term and then this will multiply with this and finally we will add them. And similarly, this minus 2 will multiply with 80,000 and 0.5 will multiply with 340,000 and we will get this value. So this is our least square solution of a data set which we have selected for this particular problem. We can see that the bias value is 0 and the weight is 10,000. So in this lecture, we learn how to implement least square regression. We select a numerical method in order to understand all the steps of a least square regression. We see that we have obtained the optimal value of the weight, which is 10,000, and the value of bias is 0 for this particular example. So this is the optimal value of weight and bias, and these weights and bias represent the best regression model on this dataset. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.